Okay, let's unpack a concept today that really pushes the boundaries: language, computation, maybe even reality itself. Imagine, if you will, a world where understanding why an AI does something isn't this, complicated reverse engineering job, but it's right there, clear as day, just part of how it works. Today, we're diving into a potential breakthrough from Thetadriven Corporation. They claim they've achieved just that. It's about this profound unity, they say, between semantic meaning and, well, physical reality inside the computer. They call the system FIM, Field Aware Information Management, our mission today. To explore how position like where data sits isn't just a place for meaning, but somehow is the meaning, and what that can mean for you. So the sources we've looked at describe something that honestly feels a bit like a philosophical paradox, right? For ages, we've thought of meaning as, abstract, separate from where the bits and bytes actually live. But this He of M system, it suggests position doesn't just point to meaning, position is meaning. How do we even start to wrap our heads around that?
It's fascinating, isn't it? It basically collapses a distinction we all make almost without thinking. Think about a regular library. The call number on a book, its position, it's arbitrary, really. You absolutely need the card catalog, or nowadays a search engine, right? A translation layer, to connect that spot on the shelf to what's actually in the book.
Right, the translation layer.
Exactly. With FIM, that layer just disappears.
Yeah.
It's maybe closer to how our own minds seem to work. When something is most important to you right now, it's not like it's stored in a box labeled important. It is the thing that's front and center in your thoughts.
Yeah. First in line.
First in line. And the mathematical beauty they seem to have found is that importance and physical storage position become identical. So where normally importance might be, I don't know, score like 0.865, in FIM, that importance literally is position 1.
Okay, so no more abstract score. Importance is position 1. That really hammers home that map territory distinction idea, doesn't it? The idea that the map, our representation, is different from the thing itself.
Precisely. Here, the map, the position is the territory, the importance. And this isn't just some clever storage trick, it's fundamental. It means execution is explanation. The path the system takes through memory is its reasoning, transparent.
Execution is explanation. Wow.
And structure is semantics. How the info is arranged is what it means. And accessing position 1 is an intentional act. It reflects purpose. We're talking about a kind of unity that, honestly, most programming, most philosophy assumes is impossible.
This is where it gets really interesting, especially for anyone, frustrated with AI being a black box. Our sources point out 3 big implications from this. Unity principle. First, that collapse you mentioned. Execution is explanation. Does that really mean the AI black box problem is solved? Is it dead?
Well, it certainly throws a wrench into traditional AI explainability, doesn't it?
Right.
Think about a typical neural network. Millions of parameters, right? Each is just a number, a weight at some memory address. That number, 0.73 or whatever, stored at address 0x ABCDE.
It doesn't mean anything by itself.
Right, it's just a weight. Exactly. So tools like, S.A.P.H or Lime, they try to work backward after the decision is made, poking the box, trying to guess why. But if position is meaning, then accessing position 1 isn't just grabbing data. It literally means I'm considering the most critical factor now. The physical path through memory is the reasoning. Every single memory access is semantically clear.
So a memory location isn't just holding the data for heart disease risk factor.
It is heart disease risk factor.
Yeah.
That location is that concept in that context. The box turns to glass. You could just watch the reasoning unfold.
Okay, that's huge. And it leads to that third thing you mentioned, computational intentionality. Philosophy has wrestled with this forever. How can physical stuff like neurons or silicon be about something, have intent? Are you saying Fairman systems genuinely know what they're doing in a way current computers just don't?
Right. Well, traditional computers really struggle here. Bits are just bits. Meaning comes from outside, from us programmers, right? The computer just follows instructions. It doesn't inherently intend anything. But with FIM's unity principle, the physical position embodies the semantic intention. Accessing medical emergency at position 1, that is an intentional act within the system's logic, because position 1 means highest priority.
So the act of accessing is the intent.
Precisely. The access pattern itself is the system's intentional behavior. It doesn't need another layer to interpret it. The execution trace, that path through memory, is the complete self-contained explanation. No translation needed. It's like a form of self-explanatory computation. Maybe even a sliver of computational consciousness, in that narrow sense.
Okay, this sounds almost too good to be true. Like the holy grail for AI transparency and maybe more. How does this actually work under the hood? The sources mention ShortRank and this formula, S.A.P.H. Can you break that down for us?
Right, S.A.P.H stands for Semantic-Aphysical Hardware. And the key idea is that this isn't something they engineered in the usual sense. It's something they claim to have discovered. They found that the best way to structure, meaning semantic, the best way to lay out memory physically, and the best way for the hardware to access it, hardware, they're all mathematically the same structure, identical.
Identical. How?
Through this mechanism called ShortRank. Think of it as an algorithm that's constantly dynamically reevaluating and reorganizing memory. It figures out the semantic importance of every piece of data for the task at hand right now. Then it physically places the most important stuff closest to the CPU in the prime positions, like position 1. So position 1 isn't just some random slot. It's dynamically assigned to whatever's most important for this specific decision, this microsecond.
And importance isn't just a feeling, it's measurable.
Exactly. It's objective, based on things like frequency of use, criticality, impact, how recent it is. ShortRank calculates this and keeps the memory perfectly sorted by importance all the time. It maintains that CPU alignment.
So we're really down at the level of CPU physics now. Sources talk about a ground truth chain. What's going on with the actual silicon that makes this S.A.P.H thing work and gives it power?
Yeah, absolutely. Level 0 is just hard physics. You can't argue with it. Sequential memory access reading data in order is way, way faster than jumping around randomly, sometimes 100 times faster.
Because of CPU caches?
Right, exactly. Caches predict you'll need the next chunk of data, so they prefetch it. Random access breaks that prediction. So when ShortRank organizes memory by semantic importance, and that dictates the physical layout, P, the system naturally accesses data in order of importance, which means it reads memory sequentially most of the time, which means it aligns perfectly with how the hardware, H1, wants to work, maximizing cache hits. S aligns with P, aligns with H. It's this identity they uncovered. Like finding eMMCR. It was apparently always true about information. They just found the equation.
And this alignment, this unity principle, it's not just theoretical. There are actual numbers, proof.
Oh, yeah, absolutely. The sources are quite specific here. They show empirical measurements validated across Intel, AMD, Apple Silicon. They're seeing 8.7 to 12.3 times performance improvements over traditional databases or data structures.
8 to 12 times.
And it's coupled with these crazy cache hit rates, 99.7%. That's near perfect prediction by the hardware. And they measure this stuff really deeply using specific hardware counters, for L2 cache misses, branch miss predictions, pipeline stalls, super low level. They even calculate this trust score in real time. It's like 1 minus the difference between what the semantics say should happen and what the hardware does, divided by the say.
So S.A.T say.
Measuring the gap between semantic intent and physical execution.
Exactly. And they are measuring this trust, this alignment, down at the sub-microsecond level. It's objective hardware proof that the system is doing what it claims and doing it incredibly efficiently.
Okay, the speed is impressive, but the implications, they feel much bigger. When execution is the explanation, what does that mean for, say, a doctor using an AI for diagnosis? Or for legal teams in discovery? Industries where why really, really matters. It changes the game completely. Take legal discovery. Instead of lawyers drowning in terabytes of logs trying to piece together why some trading algorithm or autonomous system did something, you could potentially just present the access trace. It looked at position 1, market volatility, and then position 47, competitor action, then position 203, historical precedent. And anyone like a jury can grasp importance ranks. The sources suggest this could cut discovery costs by like 99%.
Wow. And for medicine?
Think about diagnosing complex conditions, navigating those, 68,000 plus ICD-10 codes. A system like this could give doctors critical insights in sub-milliseconds, always prioritizing the most urgent factors based on the patient's current state. It sort of mimics how expert doctors think, right? Focusing on the most important symptoms first. The explanation follows the importance gradient naturally. You're not reconstructing the reasoning, you're watching it happen.
So it's not just making explainable AI or XAI better. It sounds like you're saying this makes a lot of current XAI methods kind of obsolete. It's a different paradigm.
That's the argument, yeah.
But surely a shift this big, there must be challenges. Skepticism. People are very invested in current methods.
Absolutely. As the sources stated, when position IS, meaning execution IS, explanation, no translation required, the access pattern is the reasoning. They call it a revelation that sort of solves the computational consciousness problem, at least for self-explanation. The biggest challenge is probably conceptual. Decades of computer science are built on separating data and meaning, then trying to bridge the gap later with things like XAI. FIM says that separation was maybe the wrong starting point. It requires rethinking fundamental architecture. That's a huge mental leap for developers, for researchers. It implies maybe current XAI is trying to solve a problem that in this paradigm doesn't even exist because the explanation is inherent.
The sources wrap up with something even more profound. They say this isn't just engineering, it's a reconceptualization of reality. Meaning isn't mapped to physics, meaning IS physics. That
Mm.
meaning has mass, position, momentum. Is this metaphor or?
They are adamant it's not metaphor. They point to those hardware measurements as proof that meaning is physically real in the system. Semantic weight is physical weight importance translates to energy, to processing priority. Semantic location is a specific memory address. And ideas, concepts, literally carry other related ideas along with them, like momentum, influencing the next access, the next thought. Their conclusion is stark, semantic is physical. Yeah. And the really mind-bending part, they suggest these weren't ever actually two different things that we need to connect. They are one, always were.
Wow. So the ghost in the machine, never a ghost, always machine. And the machine was never just dumb hardware, it was always meaning. One unified thing. That is, yeah, that's a lot to think about. It suggests a kind of inherent order we haven't seen before. So today we've taken a pretty deep dive into Theta-Driven Corporation's Unity Principle, this idea that position is meaning. We've explored how this apparently reveals a fundamental measurable link between semantics, physical memory, and hardware operations. It really challenges our basic assumptions about computing, and yeah, it could radically change how we build, use, and crucially trust AI systems. For those of you wanting to dig deeper into the technical side, the validation Theta-Driven offers resources, patent details, an open source tool called Intent Guard, but the bigger questions remain for you, listening. What does it mean when a computer thinking is its own explanation? Instantly clear, verifiable? And what becomes possible when meaning isn't just abstract, but has physical properties we can measure mass, position, momentum? Maybe the future of AI isn't just about building smarter machines. Maybe it's about finally understanding the intelligence already woven into the fabric of reality itself.